So let's do a couple of examples. They first want us to expand each of these logarithmic expressions into a sum or difference of logarithms. What this means is we may have more than one logarithm, but no exponents or multiplication or anything like that. Don't forget your bases, don't drop. So you may notice that in our argument, we have multiplication, 9 times x squared times y to the fourth. When we are multiplying like bases, we add exponents. So we can split up this logarithm as log base 3 of 9 plus log base 3 of x squared plus log base 3 of y to the fourth. And we really don't want those exponents there either. So we're going to use that granddaddy that I told you about, and we're going to take all those exponents and move them to the front of their individual logarithm. So log base 3 of 9 plus 2 log base 3 of x plus 4 log base 3 of y. Now it looks like we're done because everything is simplified, except we can go further with that first logarithm. Notice you have a base 3 and an argument of 9. There is an exponent. 3 squared gives us 9. So this entire logarithm can be replaced with the number 2. So we get 2 plus 2 log base 3 of x plus 4 log base 3 of y. In our next logarithm, we have a couple of operations. We have multiplication on the top, but we also have division. So let's work with that larger operation of division first. Remember, when we're dividing like bases, we subtract exponents. So when we're dividing the argument in the logarithm, we're going to split it up with subtraction. So the log y is pretty much set, but there's more that we can do with the log 1000 square root of x. They're being multiplied. So we can rewrite this multiplication as log of 1000 plus log square root of x minus log of y. Now, even though that square root of x looks like it's simplified, we can write it with a fraction exponent. So log of 1000 plus log of x to the 1/2 minus log of y. So if you've forgotten some of those rules, if you have the nth root of x to the r, it can be written as x to the r, but divide that exponent by the index n. So that's why this is an understood 1. Understood square root, that's where the 1/2 came from, just a little reminder. So we can move that 1/2 to the front of that particular logarithm. And again, it looks like we're done, except it's a common log. Common log is a base 10, which means that first logarithm can be simplified into just an integer. We have the log base 10, 10 cubed would give us 1000. So that logarithm would be the exponent 3. So we get 3 plus 1/2 log x minus log y. That would be our final answer.